Hello, good day. This time I will be discussing about derivative rules. So there are many derivative rules that we can use for solving derivatives. So the most basic one, or the first rule of derivative, is the derivative of a constant. When we say constant, this is any real number, may it be a natural number, integers, rational or irrational. So if f of x, or the function of x, equals c, so c here is the constant, then f prime of x equals 0. So the derivative of any constant is 0. So example 1, let the function of x equals 7. So 7 here is a constant. This is a natural number. And find f prime of x. So first derivative. So we'll solve here. F prime of x equals 0. So that's it. Another example. Let y equals 347.9 pi square root of 14 divided by sine pi over 9. Find the first derivative, or y prime. So pi here has a value of pi equals 3.14 that. So there are numbers preceding this 3.14, but let's just use 3.14 for the value of pi. So this is 347.9 pi square root of 14 divided by sine pi over 9. So sine pi over 9 has also a value. So therefore, this expression here is just a constant. So y prime equals 0. Another is derivative of a linear function. So if f of x, or the function of x, equals mx plus b, then f prime of x equals m. So m here is the slope. M here is the slope of a line. Okay, so its derivative is m. So example, for f of x equals x, find f prime of x. So f prime of x equals 1. So why is it 1? So here in the given f of x equals to x, there is a constant here, 1. So that is 1 here is the slope. So any variable that has no constant, there is always one constant of that variable. So the slope of that given f of x equals to x is 1, so its derivative is 1. Derivative of a linear function, another example, 4. So find the derivative of 37x minus 14 with respect to x. Okay, so, or, actually, this example can also be written as the derivative of 37x with respect to x minus the derivative of 14 with respect to x. It can also be written like this one. But we can also use this derivative of a linear function. So this rule. Okay, so the rule says that f prime of x equals 37. So 37 here is the slope. M equals the slope. So we can also use this solution. So the derivative of 37x with respect to x. So, and minus derivative of 14 with respect to x. So 14 here is a constant. So the derivative of this 14 is 0. So 0 to siya. And the derivative of 37x is just 37. So it's just the same with this answer. Next, power rule, version 1. So there's version 1, of course there's a version 2. Let f of x equals x raised to the power of n for a positive integer n. Then f prime of x equals n times x raised to the power of n minus 1. So this will be the formula for its derivative. Example. So find the derivative of x raised to the power of 49 with respect to x. So in the given, n here is 49. So therefore, its derivative, f prime of x equals, so copy the n, 49 times x, and then n is 49 minus 1. So we're just following the formula here. So solve f prime of x equals 49 times x raised to the power of 48. So this is the derivative of x raised to the power of 49 with respect to x. Next is a constant multiple rule. If f is differentiable at x and g of x equals c times f of x, then g prime of x equals c or constant times f prime of x. So how will we use that? Example, find the derivative of 7x cubed with respect to x. With respect to x. So according to the formula here, we will separate the constant. So the derivative, so the given is g of x equals 7x cubed. So 7 here is the constant, and this x cubed is the f of x. So following this formula, g prime of x, or the derivative of x, equals c, which is the 7, times the derivative of x cubed. So this derivative of x cubed, we can apply the power rule, which is the derivative of x raised to the power of n will be n x raised to the power of n minus 1. So 7 here times n, which is 3. Let's just use bracket. 3 times x raised to the power of 3 minus 1. So solving here, simplifying this, 7 times 3. So the derivative will become 21x squared. Squared because this is 3 minus 1. So the remaining will be 2. So the first derivative, or the derivative of f of x or g of x, equals 21x squared. Next is sum rule. If f and g are differentiable at x, then f plus g prime of x equals f prime of x plus g prime of x. Example. Okay, so these are the given. So in this function of x, there are 3 expressions. So we can do here is f prime of x equals the derivative of 3x raised to the power of 4 plus the derivative of x squared with respect to x plus the derivative of 2x with respect to x. So we can differentiate it one by one. Okay, equals. So this would become 3 times 4 x raised to the power of 4 minus 1 plus 2x 2 minus 1 of 2. This is 2 minus 1 plus 2x raised to the power of 1 minus 1. So any variable with any variable has, if there is no power written on it, there is automatic power of 1 on that variable. So 1 minus 1 is equal to, first derivative, this is 12x cubed plus 2 x plus, so this one here, x raised to the power of 1 minus 1, this will become x raised to the power of 0. Any variable or any number raised to the power of 0 equals 1. So this is 2. This will become 1. This x raised to the power of 1 minus 1. This is 1. So 2 times 1 equals 2. So this is the derivative. F prime of x equals 12x cubed plus 12 plus 2x plus 2. Next, difference rule. If f and g are differentiable at x, then f minus g prime of x equals f prime of x minus g prime of x. Example. So this difference rule is very similar to the sum rule. So this will become f, we will use this one. In the example of sum rule, I didn't use the formula given. So I will be using this formula, f minus g prime of x equals, this will become f, derivative of x cubed with respect to x minus derivative of 4x squared with respect to x. So this will become, I will write this f minus g prime of x equals 3x raised to the power of 3 minus 1 minus 4 times 2x raised to the power of 2 minus 1. So this will become 3x squared minus 8 because this is 4 times 2 is 1. 8 times x. So this is 2 minus 1. So x will be the remaining variable. So this is the derivative. 3x squared minus 8x. Next will be derivatives of polynomials. When you say polynomials, there is one variable x with the different power. So here in the example, there is a power of 7, 4, 2, and then there is 1. Okay, determine the derivative of 5x raised to the power of 7 plus x raised to the power of 4 minus 8x squared plus 7x minus 3. So this will become f prime of x equals derivative of 5x raised to the power of 7 with respect to x plus derivative of x raised to the power of 4 with respect to x minus derivative of 8x squared with respect to x plus derivative of 7x with respect to x minus derivative of 3 with respect to x. So there are 4 derivatives to solve. Okay, this is 5 times 7 x raised to the power of 7 minus 1 plus 4 x raised to the power of 4 minus 1 minus 8 times 2 x raised to the power of 2 minus 1 plus 7 x raised to the power of 1 minus 1 minus 0. So 3 is constant, so its derivative is 0. Equals 5 times 7, 35 x raised to the power of 6 plus 4 x raised to the power of 3 minus 16 x x1 plus 7. So x raised to the power of 1 minus 1, this will become x raised to the power of 0, and this is equivalent to 1. So the remaining is 7. So this is the derivative of the given polynomial. Another example. Find the first derivative of y equals 4x cubed minus 2x squared plus 5. So y prime equals derivative of 4x cubed with respect to x plus derivative of negative 2x squared with respect to x plus derivative of 5. So this will become 4 times 3 x raised to the power of 3 minus 1 minus 2 x raised to the power of 2 minus 1 plus 0. So y prime equals 12x squared minus 2x. So this is minus 4. Oh, there is another 2 here. Minus 4. This is 4. So y prime equals 12x squared minus 4x. Higher order derivatives. Higher order derivatives meaning there is a first derivative, second derivative, third derivative, and so on. So there are higher derivatives. Example, this function given f of x equals 3x cubed plus 7x minus 5. So its first derivative is 3 times 3x is the power of 3 minus 1 plus 7x 1 minus 1 minus 5. So this is equal to 9x squared plus 7. Its second derivative, f double prime of x equals 9 times 2 x raised to the power of 2 minus 1 plus 0. So this will become 18x. Third derivative, f prime, f triple prime. Third derivative equals 18x raised to the power of 1 minus 1, or this is equal to 18. And if we go on, fourth derivative, fourth derivative, fourth derivative of x, let's use 4, equals 0. So that is the higher order derivatives. Next, product rule. If f and g are differentiable at x, then the derivative of f of x times g of x equals f of x times g of x plus g of x times f prime of x. Example, use the product rule to differentiate y equals 3x squared plus 7 times the quantity of x raised to the power of 4 plus 12x minus 9. So, this one will be the f of x, and this one will be the g of x. And we will find the f prime of x equals 3 times 2 x raised to the power of 2 minus 1 plus 0. So this is 6x. And then the g prime of x equals 4x raised to the power of 4 minus 1 plus 12x raised to the power of 1 minus 1 minus 0. Minus 0. So this is 4x cubed plus 12. So this is the g prime of x and then the f prime of x. And using the product rule to differentiate, y prime equals f of x times g prime of x plus g of x times f prime of x. So equals, let's check. Okay, we have the correct formula. F of x is 3x squared plus 7 times g prime of x 4x cubed plus 12 plus g of x raised to the power of 4 plus 12x minus 9 times f prime of x 6x. So simplifying this one, this will become 12x raised to the power of 5 plus 36x squared plus 28 x cubed plus 1484. This one plus 6x raised to the power of 5 plus 12 to the 172 x squared minus 54x. So this is equal to sum the variables with the same power. 12 plus 6. This is 18 x raised to the power of 5. And then the cube. 36 cube. 28 plus 28 x cube plus squared 36 and 72. This is 108. Am I right? 108 x squared minus 54x plus 84. So this is the y prime or the derivative. Okay. Next will be the quotient rule. I will be making another video for this quotient rule. So I hope you understand my discussion about derivatives. There will be part 2.